Welcome back, everyone, to the series titled Generalizing Medical Science in Terms of Self-Dual Structure and Teleodynamics. We are still recruiting our technical terms so that we can make this more practical without losing credibility or encumbering our precision. These technical terms are novel, but they're necessary. They're a little bit clunky, but necessary. If we don't establish, well, first of all, medical science is riddled with all kinds of euphonic and pretty ineuphonic terminal expressions. I mean, we've got so many. Some of them are euphonic, like I said. A lot of them are just almost grotesque. And most of these refer to terminal elements and terminal operations. In a specialized medical scientific context, are considered to be theorist-derived, theorist-observed processes, which are filtered through the theorist but do not critically depend on the theorist's cognitive syntax, cognitive perceptual syntax. Now, the reason why we're using all these new terms is because there needs to be an ontological level of medical science which defines terminal elements, terminal relations, and terminal operations in terms of terminal non-terminal elements, terminal non-terminal relations, and terminal non-terminal operations. In other words, we're defining everything in terms of self-dual structure. And self-dual structure evolves teleodynamically because every single element, relation, and operation is utility seeking slash satisfying. So we have in CTMU terminology conspansive cycles between terminal non-terminal phases of every single element, namely body, relation, namely mind, and operation, namely spirit. These are conspansive cycles, and more esoterically, they would be considered incarnation-discarnation cycles, where incarnations are semantic instantiations, terminal semantic instantiations, and discarnations would be non-terminal syntactic generations of the instantiations, incarnations, or selections. A lot of synonyms, actually, are going to, you know, provide us with training wheels as we wade into the murkier waters of our series. And so, thus far, only two videos, two segments of the series have been scripted slash read. We now have a running document where we're going to stabilize our expressions because otherwise I get too nonlinear and, well, imprecise. So, let's see if there's anything else before we move to the running document. As mentioned, this series will ultimately become practical. So, we're not gonna, be publishing a generalized medical science textbook through this series, right? Through what amount to publicly available personal notes. But we are going to need to oscillate between technical and practical aspects of this ontologically generalized medical science. But I do want this to be useful, and so it has to ultimately be practical. In the far future, my sister and I will probably co-author an introductory textbook on generalized medical science in terms of the biopathic method and create a documentary series in which we discuss our own personal experiences, interview others, cover medical miracles, placebo effect, anesthetic awareness, or anesthesia awareness as it's called, coma consciousness, near-death experiences, and ultimately self-healing or anomalous healing, sometimes called psychic surgery. There's a lot of terms, chakra alignment, and how we have to. One of the goals of this series, which will have to take some time, is to align the chakra system with the physical system that we understand, the stratified physical system of human bodies. Is there a principled relationship? And if so, what does that relationship actually look like, theoretically and practically? So here we go. Let's go to the running document here. Now, I do warn you, this is still going to be a little bit dry, but it's necessary background. Again, so that we don't lose credibility or precision. So, I'm going to read with addenda. We should know now that every system is a teleodynamical system. Physical systems are executive subsystems, and mathematical systems are, we can say, syntactic programmatic subsystems of teleodynamical systems. Physical systems are purely semantic, mathematical systems are purely syntactic. But we know now that a self-dual syntax which incorporates its semantics as an executive subphase is necessary for us to actually understand how any system functions. And where we here mean functioning as evolving, where all functional behavior, including dysfunctional behavior, would be a form of evolution. So we're generalizing evolution, right? Ordinarily, we have, biological evolution is actually, most physical systems are not said to evolve, but if no physical system if a non-biological system is not said to evolve, then how did Darwinian evolution, how did, sexual and non-sexual or natural selection come about at all, right? How did the universe come about? Well, there has to be evolution built into every system. Therefore, it is teleodynamical system. So in teleodynamical systems, reading now, which are jointly defined generalizations of physical, aka purely semantic, and mathematical, aka purely syntactic systems, any syntactic operation is intrinsically linked to a semantic instantiation, and any semantic instance element terminus is a utile product or output of a utility-seeking / satisfying process. So we can now identify causality with utility. And of course, causality is not just linear, it's also nonlinear. And, in quantum theory, we have, retrolinear or retrocausal processes, but ultimately we have to update retrocausality in terms of what the CTMU would term metacausality, which is a nonlinear future to past causality which incorporates its past to future pseudo-causality as a mechanical limit, which we'll talk about more. When we confine teleodynamical systems to physical systems, you get randomized / mechanized systems, which have future to past mechanical dynamics and past to future random dynamics. And when you confine teleodynamical systems to mathematical systems, then you have a black box, namely a human mind, which is defining, describing, and interpreting a system which then evolves mechanically or derivationally. And randomness through probability theory, statistics, etc., is structured in terms of random variable distributions and probability density functions incorporating randomness and all sorts of devices which are actually pseudo-random because they're situated within an overall mechanical mathematical system. Okay, so teleodynamical systems are both physical and mathematical. They're both semantic and syntactic, terminal, non-terminal. So such systems possess a self-dual syntax. Now that self-dual syntax, as we've already introduced, involves self-dual elements, namely terminal, non-terminal body complexes or products. They're terminally oriented. All body complexes are terminally oriented, and they relate to a definitional level of syntax, which we've called physical syntax. Self-dual relations are non-terminally oriented, but they still have a terminal aspect because, again, you can't have a relation without composite elements or relands, elements that are related. And these are mind complexes or properties, predicates, and self-dual operations, which are terminal, non-terminal, spirit complexes or processes identified with soul. And as we mentioned, physical elements are related to definitional syntax, physical syntax. Relational elements are related to a structural or mathematical syntax, and perceptual operations are related to a qualitative perceptual syntax. Okay, so these are subsyntaxes of teleodynamical or self-dual syntax. If we're focused on the structure of the syntax, it's self-dual. If we're focused on the evolution or the semantics of the syntax, we can call it teleodynamical. Okay, and if we restrict this syntax to physical executions, it is mechanical in a physical sense. If we restrict this syntax to mathematical systems, it is mechanical in a derivational sense. So there's two senses of mechanical here, which we will also, in the physical sense, let's just get this out of the way. In the physical sense, mechanical means linear causal. Okay. In a mathematical sense, it means derivational. It's a proof theoretic notion of mechanical. All right. So, as we mentioned, self-dual elements are the definitional level of syntax. Self-dual relations are the descriptive level of syntax, and self-dual operations are the interpretative level of syntax, which co-evolve in an automorphic manner, meaning each aspect or phase of the system, definition, description, and interpretation, requires and recruits the others, rather than being disjoint from each other. So dualistically, which is what's standard, elements are arbitrarily or aesthetically chosen terminal symbols, which we use as part of a notational language. And of course, we should know that bodies are not usually thought to be terminal symbols, but they are. They're terminally oriented symbols, even though they're self-dual elements, so they have to be terminal, non-terminal symbols. But we'll get to the self-dual generalization in a second. But dualistically, aka mathematically, you can choose any symbol you want to represent. You can choose any symbol to populate your symbolic alphabet of your formal language or system, and the relations would be non-terminal symbols which serve as dynamical placeholders for the properties of the terminal symbols. And of course, these relations would begin with axioms, but the axioms would then extend to all sorts of relations between the elements, which are non-axiomatic or post-axiomatic. And the transformations would be dynamical productions communicable between language users. So, mathematical transformations would be functions, operations that carry elements into new relations and define new elements, right? Oftentimes in mathematics, we think of transformations either grammatically or in terms of generalizations of elements, right? Numerically, you have the natural numbers, which are then generalized into the integers, which are then generalized into the rational numbers, then generalized into real numbers, generalized into complex numbers, quaternions, octonions, p-adic numbers, etc. You can do this with any element, which again is a terminal symbol in a mathematical sense. And those generalizations are usually driven by restricting the operations or relaxing the operations. You restrict an operation to, let's say you restrict multiplication to a binary operation, then you can start defining things like prime numbers, which don't satisfy binary multiplication. That's how you get prime numbers, right? If you didn't restrict multiplication to a binary operation, you wouldn't be able to define prime numbers, right? So you have to then relax that restriction of multiplication. Then you can start defining a relaxed form of multiplication, which resolves prime numbers, right? And so, anyway, that's how you dualistically consider elements, relations, and transformations or operations. But self-dually, elements have to be requantizable terminal, non-terminal objects or body complexes. Relations have to be infinitizable non-terminal, meaning they're non-terminally oriented / terminal predicates or mind complexes. And transformations have to be the teleo, meaning utility-seeking and satisfying dynamical productions, communicable not only between language users, but also language programmers. Humans are language, all objects actually, are language programmers. We program in the non-terminal sense, and we use in the terminal sense. And programming and using or executing are, of course, self-dual as well. These are seemingly bizarre classifications, but in fact should become intuitive eventually, which means we won't need to go over this again and again and again. We're going to take it for granted as we move forward. Now, you should note that quantization and infinitization, akin to actualization and potentialization in the CTMU, respectively refer to terminal semantic selection, aka what we consider to be evolution, and non-terminal syntactic generation, both forming conspansive cycles, where conspansion is the operation, the self-dual operation, which unites quantization and infinitization. Quantization would be a generalization of a stratum relative generalization, stratum distributive, generalization of quantum mechanical wave function collapse. Okay, so any object would be a collapse of a property, an instantiation of a property, aka a relation. Things become very natural and intuitive when you think of it this way. Quantum mechanical wave function collapse is no longer mysterious, right? And of course, then, what does a quantum wave function correspond to? It corresponds to the infinitization or the expansion, which, of course, expansion is a geometric analogy of something which is purely syntactic, meaning the non-terminal syntactic generation of the potentials corresponding to the elements or collapses. These are conspansive cycles of selection/generation or incarnation-discarnation. Okay, so a collapse, even a quantum mechanical wave function collapse, is an incarnation of a state, aka a body. And the discarnation would be the infinitization of that state, which, of course, is what's missing in our scientific and mathematical discourse. So, in other words, elements, aka collapses, and relations, aka, wave functions, if we want to stick to the analogy here, would be the selective/generative phases of what we would call conspansion, and in an evolutionary sense, telic recursion, which we can, terminologically convert to teleodynamization. So, a lot of terminology here, but we're going through it fairly, slowly, and gradually. So we should be able to pick this up as long as we can, think this through carefully and really understand. We should already understand that elements, relations, and operations or transformations are self-dual to each other. You can't define an element without a relation. You can't define a relation without an operation that produces the definition of the elements, and the definition itself would be a relation, okay, between element and non-element, if nothing else, between element and complement. So we should understand that, but we should also start to understand that the self-dual form of an element is a terminal non-terminal object. The self-dual form of a relation is a non-terminal terminal predicate, and the self-dual form of a transformation would be a teleodynamical production, readable, communicable between language programmers and users, which means that what we now think of as, well, we have a bunch of, material objects out there in a vast universe. We don't know why the universe came into being, and we don't really understand how the objects relate to each other, but let's use the scientific method to understand it. That now gets converted to what we've been calling the syntactic method, which fuses the axiomatic and scientific methods, sub-methods, in such a way that what we understand as bodies or objects or products are now self-dual elements, which the scientific sub-method can focus on, and the relations between those elements, would be understandable by the axiomatic sub-method, which would now be considered to be non-terminal relations, non-terminal terminal relations, and the transformations proper would be what the syntactic method can focus on, because those are the most general. That's what motivates and stabilizes the entire system. And of course, the universe is one, teleodynamical system, and every system within it would be a teleodynamical subsystem. There is no system which is non-teleodynamical. That's an illusion. That's a mechanical / random restriction of our ontology and phenomenology. All right, so now that we have that down pat, at least on an introductory basis, we can move to understand how the ordinary definitional level of syntax, aka physical syntax, is defined, and how mathematical syntax is dualistically defined as well. So, we're not going to yet in this episode get into how we self-dualize the syntax of definition, aka physical syntax, nor the mathematical syntax, because we have to set up how these syntaxes are ordinarily defined. Okay? So, the definition of any system, relation, or operation requires elements, objects, instances, termini to terminally instantiate it, without which it cannot be syntactically accepted or registered as existent. Physics and its stratum relativized extensions, chemistry, biology, psychology, sociology, anthropology, and so on, mistakenly places its entire focus on terminal elements, relations, and terminal operations, right? This is called terminal confinement in the CTMU. And the following classifications and their existence is basically paradoxical in a non-instrumental sense. So, here are the terminal elements. You've got material products, elementary or composite bodies, subatomic complexes, atomic complexes, molecular, cellular, histological, organological, physiological, familial, social complexes, all the way up to celestial complexes, like planets, stars, moons, star systems, galactic cluster systems. Ultimately, the cosmic or cosmological system would be itself a material product when considered as an aggregate of all of its bodies, as a composite body. It can also, however, be considered a limiting terminal relation, a limiting spatio-temporal property, or interconnected network of all those elementary and composite bodies. These are pseudo-mechanized properties. I say pseudo because their mechanization is ultimately an illusion. These are all utility-seeking / satisfying properties. So, distance, duration, orientation, proximity, speed, velocity, energy transfer, temperature, pressure, velocity, generalizing to higher order properties applicable to biological systems, such as self-insolubility, self-motility, self-regenerability, differentiability, regulability, are all spatio-temporal properties. They're terminally confined relations. Why? Because we're not actually including their utility. Why is distance utility-seeking or satisfying? Why is duration, orientation, etc. utility-seeking / satisfying? Well, we haven't defined physical objects in terms of, well, we can call them evolutionary cycles, which are strata of teleodynamics. So, first density, second density, third density evolutionary cycles are those with which we're familiar, but we haven't defined them as strata of teleodynamics. We haven't defined, least action, least energy, least time principles as principles of utility. We haven't understood that physics is reinterpretable in terms of utility, right? And for that matter, chemistry, right? We don't consider, this is the whole point of teleodynamics, right? Everything involves utility, everything, which is defined from the top down as self-utility and from the bottom up as emergent utility. As well, this bears on things like free will, which we'll get into, which is really a morass later on. And then finally, we have terminal transformations, which are linear, causal, pseudo-randomized processes. So, for example, energy conversions of potential to kinetic energy, localistic interactions like particle collisions, whether they're, in any phase of matter, ascendingly coordinating forms of motion such as rotation, translation, vibration, oscillation, applying to chemical and biological complexes. For example, mitotic and meiotic subdivisions are, very complex coordinated forms of motion, DNA transcription, replication, recombination. These are all highly complex forms of motion, where motion is the simplest characterization of a terminal transformation. But we have to update motion in terms of conspansion, such that we don't have any form of motion without a coupling of quantization and infinitization, actualization, terminal semantic instantiation, and non-terminal syntactic generation. Okay? So these terms seem a little bit abstract, but again, this is going to clarify a lot of our dualism that runs rampant throughout all of our scientific, fields. And that dualism leads to a siphoning off of the mathematical structure of all of our, scientific analysis. That's considered to be in isolation from and independent of our terminal reality, which is what scientific reality is. So, all right, the terminal confinement of physics and its complexified or stratum relativized extensions leads to scale variant ontologies, plural. There is one ontology. There is one meta predicate known as existence. Okay? Existence evolves. That's the teleodynamical statement. Existence exists is the self-dual statement. Okay, we can break into that later, but just leave that as an Easter egg. Language universe or property product dualism, right? Mathematical languages, programming languages are considered in terms of their abstract properties, whereas universes are considered in terms of their concrete products. We don't know how to bridge that gap, and without basically stipulating that we, theorists glue languages onto their universes as a matter of our own theorist peculiar utility. They're not intrinsic to the universe, and the universe is not intrinsic to the language. That's a problem, and that leads to rampant anti-teleological reasoning, right? Where we prefer anti-teleological interpretations of physical systems and their behavior. So the self-duality of the physical sciences, is at once intrinsic, right? The relations between elements are defined by their transformations, and of course, the relations between elements are described in terms of the transformations, and systemic. There are two senses of self-duality: minimal, aka intrinsic, and systemic, aka maximal. Their elements, relations, and transformations are uninterpretable without a unifying ontology in which physical existence is singly characterized by an identity element, identity relation, and identity transformation. So, the scientific method is not a purely empirical method in that its second step, which is to form a descriptive theory of observed phenomena, implicitly involves the logical mathematical syntax of theory formation. Right? Every theory, every descriptive theory is, characterized in terms of mathematical syntax. And that means that this idea that you can, disjoin the scientific method and the axiomatic method is fictitious. It's illusory. Right? You can't disjoin empirical and rational methods of investigation as a matter of principle. Now, we're going to close this video fairly soon, but before, we're going to get into the dualistic formulation of the descriptive level of syntax, aka mathematical, relational, or structural syntax. The structural or descriptional aspect of existence focuses on the mathematical formalism that provides a structural description of physical elements, relations, and operations through abstract, non-physical elements, relations, and operations. These two are dualistically studied, that is, in artificial isolation from their physical transducers, right? The brains of mathematicians. That's a physical transducer. And therefore, mathematics is what we would consider non-terminally confined with respect to its dynamics, the teleodynamics of the mathematical aspect of our self-dual syntax is non-terminally confined, whereas the notation is terminally confined, right? We think of all of mathematics as being confined to textbooks, which is obviously what mathematicians would object to that, but, ultimately, that's how we stabilize our mathematical results, right? So, abstract objects consist of, for example, numbers, set theoretic members, scalars, vectors, matrices, tensors, variables, groups, rings. Ultimately, any valid mathematical statement can be considered a proof theoretic object, right? Which are basically a proof itself. A valid mathematical statement could be considered a proof in and of itself if we consider its, validity to be implicit and its formalization to be extraneous. You don't need to actually formalize something as long as you understand it to be valid, right? A mathematician, for example, who has come up with a theorem and has proven it non-terminally in their mind, right, could consider that, theorem, that valid mathematical statement, to be a proof in and of itself, but it's non-terminally proven. Until that theorem is terminally proven through, terminal symbols that other mathematicians can read and verify, it would basically be considered non-terminally proven. Right? So we're already seeing how even mathematicians are engaging in a dualism between, their non-terminal thought processes and their terminal communications and notations. All right, their abstract relations would be, for example, distances, angles, spaces, structures, expressions, equations, categories. Abstract mappings would be arithmetical operations, including graphical combinatorial operations, algebraic operations, Fourier transforms, analytic operations, geometric operations, topological operations, hybridized operations, right? There are all sorts of mathematical or abstract mappings, and, these are usually considered to be static. So oftentimes mathematicians would classify operations and relations as being synonymous. Okay. Even though, of course, the reason why that's done is because the execution, the non-terminal execution, the dynamization of the mapping itself is non-terminally confined to the mathematician. The notation, which characterizes the relation, right, the equations, the expressions, the categories, etc., those are terminally confined. And so the mathematician has this tension between static, terminally defined relations and dynamic, non-terminally defined mappings that are being carried out in their minds. Right? So you don't actually perceive the execution of an arithmetical operation unless you are considering yourself to be dynamically annotating it. But dynamically annotating it means that you're including all the instruments, the notational instruments, pen and paper, screen, whatever, that mathematician's hands, and the non-terminal tools, which are implicit in the mathematician's mind. That's a dualism right there. So pure mathematics conflates syntax with semantics. We've discussed that. The semantic meaning of a mathematical object, for example, or mapping, inheres in and is identical to its syntactic structure, right? If you consider, a set full of elements, right? The elements themselves they don't need to be baseballs, they don't need to be molecules, they don't need to be anything at all. You just basically stipulate that they could be anything, right? And that's standard. And, that's also a problem because a set is a relation and the elements are the instances or the instantiations of the relation. So if you're considering a set of molecules, the molecular properties would correspond to the relation, aka the set, and the molecules themselves would be the physical bodies that are characterized by the set. So even in set theory, we can resolve the dualism fairly intuitively using teleodynamics. All right, so in this conflated context, mathematical elements are stipulated into existence, connected by mathematical relations, and manipulated through transformations. Stipulation is where the dualism comes into play, because you can just arbitrarily stipulate something into existence, you can aesthetically stipulate it into existence, but ultimately you're just stipulating. Where is your stipulative power coming from? How are you allowed? What is empowering you to stipulate the axiom of foundation, the axiom of regularity, or, for that matter, the possibility of defining a random variable distribution? Where's that coming from? How are you able to do that? Well, that's a bit of a paradox, right? Because if you physicalize the situation and think, well, it's just happening because my brain gives me processing power, well, then you can regress that all the way back to, well, why are brains mathematically possible? Why are brains furthermore mathematically necessary? Well, maybe they're not, right? Maybe the mathematics wouldn't be recognizable without, for example, a brain, but it would still exist. Well, what's bridging that gap? Why is there's this Platonic realm of static mathematical statements, static mathematical truths, and non-truths, meaning invalid conjectures, that somehow in the deep history of the universe get recognized and annotated and communicated by human brains? It's a massive paradox, right? So, the bottom line is that now we've dualistically defined physical syntax and mathematical syntax, physical subsystems, mathematical subsystems. To put them together, in principle, self-dually, structuring them self-dually, is to teleodynamize these systems into teleodynamical systems. Okay? And this is where we're going to be describing these things in terms of CTMU terminology as well. We're going to invoke terms like telons for self-dual relations, and syntactors and tellors for self-dual elements, and conspansion and telic recursion, or teleodynamization for the self-dual mappings. Okay? And this is where we're going to be headed. So, I'm assuming that you're acquainted with a lot of the CTMU terminology, and at this point, we should be acquainted with the ontology and epistemology and phenomenology of the CTMU. All right? This is not a lot of you ask me, I've gotten a lot of questions regarding, how does this CTMU concept work, and what does this term mean? I'm assuming that you've read the publications and can put those things together for yourself. There's a lot of introductory material out there on the CTMU, and this is not a CTMU teaching or tooling channel. I'm taking for granted the CTMU and inducing extensions on it related to generalized medical science and, of course, other aspects. So thank you so much for listening, and we'll see you in the next segment.